So good morning, everybody. Yeah, so if you've seen the Bourne movie, no, I have not actually been in any of the movies there. The closest I came was convincing some woman on an airplane that I was Matt Damon's brother. And we had a good conversation for about 2 or 3 minutes, and then she said to me, "Why are you in the back of the plane?" And I said, I didn't have an answer. I had to pass up. No, it's not any relation whatsoever. For those of you that were looking for a shook, he sends his deepest regrets that he was not able to make it today. I'm filling in at sort of the 11th hour for him. I will talk about the same genre of stuff. I will talk about what we're doing at Verizon. I think in his shoes, if you've ever listened to him talk, he's a phenomenal speaker, so you're stuck with me, I'm sorry. But I will do the best I can. I'll probably focus more on the application than the theory today. My background is in product management. I run product for a shook on the Verizon Big Data team. And I will give you the 10,000-foot view of what we're doing at Verizon in the area of big data, just to provide some perspectives that many people don't necessarily know. I go to Stanford on a regular basis for these recruiting fairs, and I go and I take these, go into the booths, and I sit there and I watch the people as they mill by, and they sort of look up and they say, "Verizon, okay, yeah, keep going." And because it's that look, it's that he's going to sell me a phone. Look, so there was a company, big data company next to our booth, and they were waiting in this very long queue. And I said, "What you doing?" "I'm waiting for this company. I want to talk about big data." I said, "Come over and talk to me." And we had a conversation. It was very eye-opening for them. They said, "I had no idea you were doing that. The world doesn't know we're doing that." So this is a chance for me to explain some of the things we're doing, some of the challenges that we face. And so I'll go through that in the time today. So customary slide on big data. What is big data? So that picture is not big data. So that is, as much as I love Brent Spiner and Lieutenant Commander data, that's a little Pez dispenser, and it's about 4 inches tall. That's little data, okay? So medium data would be, I got a call on my first week at Verizon, and someone said, "Hey, we've got this, all these cell towers, 100,000 cell towers, and we're trying to keep track of how many sectors each one has and what the frequency band is. And well, what do you want to do with it?" "Well, we just want to keep track of what's what and probe a little further." His Excel was getting a little sluggish. And I said, that's medium data. So if you couple all the world's data from all the cell towers and all of the fan-generated data and the Klingon homeworld map and all the things you get from Star Trek, you start to tap into that 2.5 quintillion bytes of data. Now, this is a great number. It's been around for a year or so. It's even higher now. But the fact is, that's big data, right? So what do we do with all this big data? There's a lot of different things you can do, right? And there's a spectrum of approaches you can take from a product perspective of what you want to build with big data. You know, we're not dealing with 2.5 quintillion bytes of data at Verizon, but we do have a lot of data. And so we could focus on BI reporting. That's obviously a necessity. It's very important. This is query-based. There's domain knowledge. I might be saying I have an application. I want to study to understand the campaign funnel. I want to understand certain metrics, how people are consuming my app, the content that's being used. I can track that. I can generate reports on a weekly basis. I can do revenue assurance and reconciliation. That's great. You want to add additional complexity. You want to add machine learning capabilities. We can discover things from within the data. So we can look and start to say, can we extract features and meaningful data from these data sets that we're importing in? It starts to get a little bit more complicated. And if we want to look deeper and say, provide some aspect of predictability and prediction, and maybe in a near real time, not every week or every month when I generate a report, if you've got a lot of data and you want to do that quickly, it becomes a challenge. And so the complexity goes up as I go. I probably should have put this the other way, huh? So as we go down, the complexity goes up. But the opportunity, at least from our perspective, goes up as well. And so if you look to see where Verizon is focused, we would be focused more toward the bottom of this chart. Now, that's not to say we shy away from a report that we need to create. We do that. But we are trying to really look into predictive analytics. So if, you know, maybe it would be helpful for me to, if someone's asked me, "Jeff, in one sentence, what is the mandate for Verizon's big data team? What are you trying to do?" I would say, I can't answer that question in one sentence. I talk too much, right? Give me 2 sentences and I can tell you, right? So what I would say is this. Verizon's generating a lot of data. And I'll talk about the data on subsequent slides. What is in that data, how big that data is. 2/3 of the world's traffic, I think, goes through Verizon's network at some point or another. So we have access to a large amount of data. And our team within Verizon focused on developing these advanced external-facing products. We're really trying to create products that we can put in the hands of a consumer or an enterprise to generate actionable insights for them that they find relevant, right? We want to do that on this massive data set through scalable machine learning. So these insights can lead to, well, you know, that was more than 2 sentences, wasn't it? So I failed there even. So the astute listener would say, you failed there, but I continue. So data monetization is one area for us, obviously. If we're looking to generate revenue, we can do that. For our customers themselves, they might find opportunities to mitigate their costs. Really, it's all about increasing the customer experience, right? They have problems that they're trying to solve. Can they understand their customer better? Can they attract new customers? Can they generate additional insights? And so we're trying to build product, and I'll talk a little bit about some of those products that we're building and how we're building them. So I'll start, though, with the data. I mentioned we generate a lot of data, and we do. And we have this trifecta of data that we ourselves are using for some of our initial products. And I put these together because these three together comprise the base set of data that we're using for a couple of the products I'll talk about today. Now, we're looking at a lot of different products, and I don't have time to go through all of them today. But clickstream for us, it means different things to different people. People use this sort of in a loose manner, clickstream. This is a mobile user's browser and app usage on their phone, right? So we have about 70 million subscribers that we're able to look at this type of data. Okay, we have over 100 million subscribers, but not all of those fit into our pool of data that we actually get. We don't see government phones, and we don't see phones that have explicitly opted out and things. I'll talk about that. But we're generating about 4 terabytes worth of data a day for this clickstream that's ingested into our platform. We also have location data. Now, this location data is not GPS 5-meter accuracy data. This is through triangulation of cell towers. You're able to measure timing signals and signal strength indicators, and there's some secret sauce that goes into that. And then out comes a rough estimate of a location of a mobile phone during some action on the phone. And for that same subscriber set, we're able to understand some degree of accuracy of location. And that's about 1 terabyte worth of data that we're generating on a daily basis. And then we have, of course, demographic information. This is a relatively small set of age and gender and income for about 25 million subscribers. We don't have complete coverage here, and we'll talk a little bit more about what problems that poses. But together, this is almost, it's probably about 5 terabytes worth of data. The demographic is small compared to the other things. So, but this is not all the data that we have, right? We have telematics data that we're ingesting in. We have almost 6 billion miles of data that we're collecting from some of our telematics programs. We have a fleet program where we're looking at vans and trucks within corporations. We have the Verizon Hum data, which is a consumer product used for sort of roadside assistance. Network data, of course, is a big, that actually is not what our network looks like. The rooms are much cleaner than that. There was no royalty for that picture, so I put that one in. But you can get an idea of the complexity. That's supposed to be a lot of data, right? And all those wires have a lot of data. But we're getting about 25 gigabytes worth of data from each router on each day into our system. Now, of course, there's tons of routers in Verizon's network. We don't see all of them for sure. But for what we're doing in some of the areas we're focusing on for network, that's what we're ingesting. So this doesn't mention a lot of the other data that we have from apps that are being built to video data sets that we have to publicly available data. We talk about weather, we talk about traffic. Some of these things are ingested or can be ingested, and customer data as well. There's a big value in bringing in customer data and joining it with Verizon data and extracting additional insights. The customer may know they're a customer as well, but once they leave the store, do they really know what that customer is doing, for example? So the ability to join that and get additional insights would be valuable. So now my serious slide. Whenever I talk about data, I sort of have to talk about privacy, because one of the questions, I get two questions about data all the time. And well, the first one is, hey, can I have all your data? That's the first question. And the answer to that is no. I'm afraid I can't just send it to you on a flash drive. The second question I get is, well, what's your privacy policy? You have all this data, and it has a sort of a negative connotation. We take it very seriously at Verizon. So we have three categories of privacy. And the first is an opted-in customer. So someone who's opted into our Verizon's Rewards or Selects program is giving explicit consent. They're saying, yes, please make offers available to me. I'd like to sign up and get ads that are relevant to something I'm interested in. So there's an explicit group of people that have opted in, and so they can be treated in one pool. There's another group that's the opt-out pool. That group says, no, I don't want my data to be shared. I don't want you to see it. We don't even get that data. From within our team in Palo Alto, we don't even see it. It doesn't even come to us. And we do not use that for any purpose whatsoever. But then there's this other pool of data as well, which is sort of this middle ground. You're sort of in this limbo stage of neither opted in nor opted out. What do you do in that case? Well, we can't target those individuals, but there's still value in aggregate anonymous insights, right? So if you're looking through this data and you say, I'm interested to know what the top website is for men between the ages of 40 and 50 in the Bay Area that travel more than 5 times a month. And I want to know what is the top website that these people use. And maybe it's how to make it up to my wife.com or something like that, right? So I'm not saying I'm in that segment or I'm not in that segment. This is hypothetical, okay? But there's no way that you can trace Jeff Stribling back to that data. It's just an insight that you can get from the data as an aggregate. So anyway, that's a little bit about Verizon's privacy. So we talked about our mandate within our team, what we're trying to build out new product. We were talking a little bit about the data sets that we have access to within Verizon to make these things happen. What about the people that we have, in this data science team that's trying to hire these people to come in and work with us? What are we trying to achieve? What do we need in order to be successful when we build these products out? And this is sort of the composition. Now, Ashok would probably not show this slide talking about the fact that he's running this. He's much too modest, but he's assembled a really great team of individuals. And we're focused in maybe 4 different areas, maybe 5, it depends on how you count it. But it all starts with the data. So we have all that data we talked about. It needs to be brought into something, right? We need to have some physical place where we're going to accumulate all of this data. So we need a platform team. We need some system architecture. We need these people to build out a platform that can scale to the levels that we need to scale based on 4 terabytes worth of data or 5 terabytes worth of data per day. And we have the application engineers that are bringing this in through ETL process into our Hadoop platform. So that's the platform engineering team, which is sitting in one of those balls there. Once it's at rest and it's our system, we need to actually have the data science team start to take a look at the data, right? We need to generate these insights, and so we run these algorithms that scale on the data that we have. And since we've got these top-notch data scientists, of course the algorithms are perfect and they work well, and they spit out an answer, and the answer is 17 or 42 or whatever you think the answer is. But what does that mean? Right? So you need to have some way of interpreting the results, and so we have a visualization team that's responsible for that. How do we make sense of this? How do we explain these insights to a customer that's trying to consume this data? And then lastly, we have a group of explorers. These are our data explorers. These are the people that are understanding these sets of data that are coming in that I talked about before. What's real in there? What's fake? No, not fake, but what's noise? What's signal? And is it telling us what we're trying to ask of it? And that's an important area for us, obviously, in the data space. So we have a group of people looking at that, and that's pretty much it. Actually, I almost forgot. There's product management. Look at that. I'm a little biased there, but look at that huge bowl. This really important bowl. Okay, so that's what my team is. We're the smallest team within our group. We have a few people looking at different products and different verticals, and I'll talk a little bit about those. But we're sort of juggling this cross-functional management of these balls. There's just my visual cue of that. So let's talk about the data platform aspect of things, right? This is when we had this idea of the company, or the group within the company, it was about 3 years ago, 2013. And we had to start somewhere. So this is where we started. We started with that. That was Orion. Orion was the name of our cluster. We named it before it even existed. We said we were going to call it Orion. That was thanks to Ashok. It came from NASA. He's into celestial objects. And so that was where we started. We had an idea. We had nothing else. And over time, we gradually built that out. And after about 1.5 to 2 years, we were able to come up with our first pass of production, which looked more like that. And this is sort of what it looks like. Well, this was from a year ago, but it still looks like that today, except that cone in the middle is gone. I was just there at the end of the year last year, and that cone had disappeared. I don't know where it went, but that is still Orion. And we're able to process at this point 40 billion records on a daily basis. Well, the capacity is larger than that. That's actually what we're consuming today, and streaming up to 50 million records per second. So we have the ability to do both batch mode and streaming within the architecture. So at a high level, the architecture looks like this. You start at the bottom with the data. We talked about all those different data sets. These are fed into our infrastructure, and it's a Hadoop-based infrastructure. And once it's into the infrastructure, we're really trying to create algorithms much like you would have ingredients in a recipe. So you want to build something, you want to create these building blocks from which you can assemble a solution. So we might do reporting, of course. We might build anomaly detection algorithms. We might do optimization routines or do predictive analytics. But if we build it once, we don't want to have to build it again and again. We want to create it in such a way that it's generic enough for us to apply to many different problems. And so you see the upper arrow on the right talking about going towards solutions. Anomaly detection is a good example. Almost everything we build can make use of an anomaly detection. Whether or not I'm doing cybersecurity and I want to look for some sort of intrusion, or I'm looking at marketing analytics and I want to see what's trending and why did this spike on a given day, can I detect that automatically through anomaly detection? We can reuse that because we build algorithms at scale. So I've listed 4 solutions there today. We're building solutions in advertising, we're building solutions in market analytics, as well as security, connected devices, IoT. Those are a few of the areas we're focused on. I obviously don't have time to go into all of those today. So I'll focus on the first 2. I'll talk a little bit about advertising and market analytics. They're the most mature of the products. We've been working on these for the longest amount of time. So I'll talk about that next. There's one more slide on architecture. It's a bit of a busy slide. I'm not going to go through it. I promise not to quiz you, but it's just meant to illustrate that there's a lot of complexity to what we built out in the last 2 years. We need to be able to handle ingestions of many different types of data sets, as we talked about, in different methods, right? Through streaming or through a batch process, and taking advantage of the different technologies in our software stack. But let's go, because I want to make sure I stay on time here. Let's talk about some of the products that we're building out. The first one is called Panorama. Panorama is a dynamic audience planning tool. When would I use this tool? I would use this tool in an advertising situation. If I were interested in reaching a group of people that had some shared characteristics, I could reach out to that audience, create a campaign around that, and target them with a relevant advertisement. So I can combine the data sets that we talked about. Remember those location and clickstream and demographic data together, coupled in with some machine learning, and I can create audiences. I can understand something else about that customer set. And ultimately, with the right feedback mechanisms, I'll be able to do some optimization of my campaign based on some of the different impression metrics, some of the budgetary information that I'm given, et cetera. So that's all great, but I've got a lot of different customers, right? Or a lot of different users. I've got 70 million users, and I've got all those terabytes worth of data. I don't want to wait 4 years to get an answer, right? So how do we build something that we can get answers within seconds? That's the objective, right? And so we've been able to do that. The tool looks like this. This is actually a screenshot from the tool. I made this just on Saturday when I was preparing this slide. The behavior is very simple. You go into the bar. You can say, I want to create an audience of people. I made one called Fashion, I think. It has who went to Macy's.com, who went to Nordstrom's.com, who looked for keywords like fashion or shoes or shirts or purses or something like that. I just made it up. And you can't see it because it's all done here, but within a couple of seconds, it spat back out the answer and said, here's about 1.9 million people that I was able to find that have looked for this in the last 30 days. And roughly here's where they are. And you can see I didn't sort it by actual population. Otherwise, California would have been at the top. It's almost at the top always because there's just so many people in California. I sorted it by composition, so I could normalize due to the baseline population. And it turns out that Washington, D.C., and New Jersey are at the top. Now, I guess that makes a lot of sense. If you've ever watched Real Housewives of New Jersey, they're always talking about fashion, wearing these handbags and things. And I'm a big fan of the show. I hope you are too. I've actually never seen the show. I've never seen the show. I don't know anything about it. So maybe that makes sense. Now, I don't have to just look at that. But with that information right there, I can go out and say, oh, great, this is what I need. I need these 2 million people. I'm going to promote this new handbag and have at it. Now, fortunately, because of our recent purchase, well, maybe it's not a recent purchase. Our second most recent purchase with AOL, we're able to leverage our relationship there and activate this through the AOL platform. Our most recent purchase is a little bit more interesting. Moving on, the other thing that we see within the tool of Panorama is the ability to look at the demographics within that segment I've created. Here's the fashion. Notice how it can be compared against a different audience or a baseline audience. We've done that here. I think the teal line is the Verizon baseline. So these are just Verizon subscribers at large. And you can see this new one is skewed toward a younger population. OK, that makes sense. I also may want to ask an interesting question. Tell me the top websites visited by people in this segment. Tell me the top fashion websites. Tell me the top sports websites. And so I showed a couple of the top fashion websites there. I don't know if Pop Sugar is really considered fashion. I've never gone to the website. I don't know anything about Pop Sugar. But I think that's more gossip. That's what my wife told me anyway. So I think that just depends on how you classify these things from the categorization. But so these are the kind of capabilities that you can see, these insights that you can get. And again, this is all within 2 seconds, 3 seconds of time on the tool itself over 30 days. Now, there's additional interesting things that we're doing, right? Amplification, or maybe 2 million is not enough. Maybe I need 5 million. How do I reach 5 million people instead of 2 million? Well, I might do lookalike modeling. So we can build these algorithms that will investigate the behavior of the people in the segment and find other people that look like them, even though they haven't been to Macy's.com. So that's work for the data science team, and we've done that, and that's part of the amplification capability. Demographic prediction is another area where the data science team is spending a lot of cycles. What do you do when you don't have information about a subscriber? If you want to reach males and you have no knowledge, are there things that you can do? And yes, there are things you can do. We have tools that we're building out, Bayesian techniques, logistic regression techniques. There's a whole list of things that we're doing based on behavior and other data sets that we have. So those are areas of continued improvement for us. We'll continue to improve those capabilities to predict demographics. We'll continue to create lookalike models to enhance the overall segmentation. And that, in short, is what Panorama is. Now, there's 2 problems with this. Well, maybe there are a lot of problems, I don't know. But I see certainly 2 problems with this. If you go back and you look at this capability that's on the slide, I know a little bit about someone who's interested in fashion, and I can even tell you that they're in New Jersey. But when were they interested in fashion? Was it on the weekday, or was it in the weeknight? Was it morning? I don't know, right? Where were they? What zip code were they in? What fine granular area of location were they in? I have no idea. I know they were in New Jersey sometime last month, right? So we have that data. There is data. There is a timestamp associated with it. So can we take advantage of that and maybe answer additional questions beyond, let me serve someone an ad? Maybe there are additional market insights and information that we can glean from this data by looking at things across both space and time. And that's where this next tool comes into play, which we call Palomar. Now, Palomar has that same ability to discover audiences. And we're applying these predictive analytic capabilities, which we'll talk about, to generate insights on our customers, right? And really, it's about joining all these data sets together and see if we can understand what's happening over space and over time but also make predictions about this behavior over space and time. It becomes challenging. So like Orion, which started with nothing, we started with nothing too. We just had an idea, right? So we first wanted to look and see, within the data that we have, is there signal? Is there something that we can see that makes a lot of sense, or even a little bit of sense? And so we asked the question, let's look into our clickstream data, and let's look at the zip code of that data, and let's focus on Manhattan, and categorize these websites in a sort of a reasonable way, and let's see if we can see any signals over time in Manhattan. And so we did, and this is what we did. I don't know if we can actually see, there's supposed to be a ability to, I'm going to screw this up, I know, but I should be able to. Oh, there we, okay. So you can see now what's happening over time. I'm looking at morning, day, evening, and night. And the colors, it's too small to read, but there's areas like categories of fashion and finance and food and health and pets. And you can see that during the day on the Lower East Side, it's all about fashion. In the financial area, you expect to see finance, and you do. And at night, it changes to music, and you see the ability to, or the people's interest change over time. So it's very interesting in this one concentrated area, the ability to see behavior and behavior patterns over space and time. So we said, hey, we're onto something. There's value in this data. So what more can we do? So we went worldwide. We took it on the road, right? We said, let's explore across the nation. Each dot you see on this picture represents a zip code. Now, it looks sort of sparse in the Montana area because the zip codes are very large, and I have it represented by one dot. But imagine, if you will, I was looking to see interest in fast food, and I created segments called McDonald's and Chipotle and Taco Bell and other things like that, and I plotted it, and I said, a winner takes all. If there's more interest in Taco Bell, I'll color it purple, and if there's more interest in McDonald's, I'll color it green, etc. So this was on a given day, and McDonald's was very dominant in the data set that we had. And Chipotle had a presence in some of the metropolitan areas, and Taco Bell, which is supposed to be purple, is nowhere to be seen. Now, the next day, we noticed that something interesting was starting to happen. There was a interest in Taco Bell on the West Coast, and I thought, what is this all about? And I thought, well, for sure, this is some sort of Cinco de Mayo free taco night, right, or free taco day. It was not, actually. It was not that, because we were about a week before Cinco de Mayo at the time. This was last year. And then the next day, everything went crazy, and it completely turned purple. And I said, what happened? So I had the data scientist guys. I said, there's something wrong. Let's look into the data. Let's figure out what's going on. How did you choose Taco Bell? How did you choose McDonald's? Maybe some of your segmentation was wrong. And no, it was right. They looked into it. And what they found was that there was a link, a video on ESPN that was sponsored by Taco Bell. It had Taco Bell as part of the path. And it went viral with some last-second playoff shot. And it got passed around the internet. And the people on the West Coast were up when it actually was aired. So they caught it that night. And the people on the East Coast didn't get a treat of that video until the next day. And so it sort of made sense. And then the next day it went back to nothing again. It went back to status quo. So that was a very crude example of the ability to look at something trending over time. And imagine the tool being used to understand the efficacy of a campaign. Right? I want to be able to see, am I driving foot traffic to my store? Am I driving traffic online? This tool, with the data that we've got and the algorithms we're building out, will help to sort of identify those things. So that was the next thing we did. But this is sort of just measurement still, right? We're just measuring counts across time and space. So we wanted to add some machine learning capabilities in there. So we started asking questions about discriminant analysis. And what if I want to compare one audience versus another? Let's say I'm talking about Walmart versus Target. And I say, I want to understand what makes a target audience a target audience. Why do they go to Target? And what makes Walmart a Walmart audience? So, what are the top websites visited by people that go to Target that don't go to Walmart? Well, the answer is not going to be google.com, right? Everyone uses google.com. But what websites are indicative of loyal target customers? So we can do that, right? Now, it becomes a little bit challenging when you talk about 70 million subscribers And how many variables am I looking at? If I'm talking about TLDs and apps and POIs and zip codes, that is a lot of columns in my matrix. And so if I have a 70 million by 10 million matrix that we need to manipulate, it becomes a bit challenging to do that in quick fashion. So speaking of quick fashion, I have only a couple of minutes left. So let me just complete my, OK, good. So I've got 2 slides. So let's make it happen. So we did an example with Walmart and Target. We ran it in the Atlanta area. And we said, show us something, oh, wonderful Palomar tool. And it spat out this. And again, it's a little small to read. But we were able to highlight certain websites that were tracking with Target and tracking with Walmart. The ones that I circled were relevant to the Atlanta area only. So it made sense that we were getting this pop from the data that we were looking at. So we were able to create now some machine learning capabilities to do this deeper insight on the data. And it gradually has led to where we are today. So this is sort of what it looks like. This is my last slide. This is the actual portal. And we're able to combine measurement and prediction for 70 million subscribers. We're currently using about 2.5 million variables. We don't have POIs in this first release, but we're using TLDs, apps, and keywords and zip codes. And we can do measurement. We can do audience discovery. We can explore. We can do lookalike modeling. We can do predictive analytics through discriminant analysis. And to do that quickly has been a bit of a challenge. And over time, the engineers on the data science team have pushed that compute time down from what they were doing in Spark SQL to maybe 3 minutes. Now we're using Lucene and other tools. We're down to about 6 seconds. And the most recent measurements with the most up-to-date algorithms are trending toward about 2 or 3 seconds. So anyway, that's where the tool's at today. So I guess I'll stop there. It's sort of a sneak peek inside the hood of what we're doing within Verizon's big data team, trying to build interesting products based on big, huge data sets using scalable machine learning.
Thank you, Jeff. All right, we have time for a couple of questions, but make them short questions and long answers.
That's plenty. OK.
I was curious about your choice of focusing on externally facing products.
Yeah.
I was hoping you could speak more about why you did that versus internal products and what implications it might have.
Yeah, that's it.
Can you repeat the question?
Yeah, so the question was, why are you focusing on external products? Why not focus on internal products? And it's a good question. One of it is sort of it's a mandate from the executives. This is an area where we look to really expand Verizon's portfolio. As other areas, the growth sort of peters out, we want to look into new opportunities to generate revenue. That's not to say that we can't and shouldn't help a fellow group within Verizon generate a product or validate a product, but ultimately our objective is to put something out in market. One example, I'll give you a very quick example, is the cybersecurity. We're building out products in cybersecurity. Why not validate them internally and take advantage of that within our own company as a first stepping stone toward putting something out in the market? So,
OK, one last question. You pick.
Oh, it doesn't matter. Yeah, gentleman in the back.
You talk about speed on these audience, but the problem, I see that as a potential solving a problem that doesn't need to be solved, just to ask the question. Because you need enough click-throughs, you need enough purchases to find out what the conversion rates are, and you're not going to get that in 6 seconds. You have to run these campaigns for some period of time. So why solve for speed?
Yeah, so
Can you repeat the question?
Yeah, so the question is, in certain applications, there's not necessarily the need for speed, right? Why do I need to solve for something? There's a cost associated with it. And it is true. It is definitely true that in some cases, speed is not as critical. However, these building blocks that we're building are applicable across more than just these products that we're building. So in certain situations, speed may not be so relevant. In other cases, where we need near real-time decision-making, it becomes an issue. So the examples I gave, I would agree, less of a concern. They run these campaigns over a period of many months, and so you want the tool to be easy to use. You don't want someone to have to type something in and come back, an hour or 2 hours later. So there's a need for that, but you're right. It's not as critical as there may be in other applications like security or video.
Please join me in thanking Jeff for a great talk.
Thank you, everybody.
Yeah.